All right, today we are talking about perpendicular bisectors and how they meet at the circumcenter. So, perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. So we're going to prove this, and I'm going to kind of talk about the logic of it, and you might get it, you might not, we'll find out. So here we're given that PM is the perpendicular bisector of AB, which is kind of cool. So we know that PM, so that's line PM, is the perpendicular bisector of AB. And basically what we're trying to prove is that this distance from P, which could be anywhere on this line, I don't care where P is, it could be above the line, could be below the line, could be halfway up the line, doesn't matter. I want to prove that this line is congruent to this line. That's the entire goal. Basically, we're proving that anywhere I am, as long as I'm on the perpendicular bisector, I would be equidistant or the same distance from the two endpoints of the line. I'm going to recommend we do a triangle congruence here. We're going to prove that these two triangles that we just created are congruent, and then we can use corresponding parts of congruent triangles to prove that PA is congruent to PB. So, first things first, we're going to use the fact that this is a perpendicular bisector to show that AM is going to be congruent to BM because of the definition of a perpendicular bisector. We also have another thing, so that's a side. We can probably say of an angle, well, we'll almost have an angle. We have to do two steps first. We can say that angle AMB and angle AMP, sorry, that should be a P, AMP and the angle BMP are right angles. And this again is by the definition of perpendicular bisector. Okay. So now we can say that angle AMP is congruent to angle BMP because all right angles are congruent to each other. So now we have a side and an angle. So now we just need another side. And I see a shared side, so we're going to say that PM is congruent to PM, there's our side, by the reflexive property. Okay, so now we can say that these two triangles are congruent, but that's not exactly where I'm wanting to go. It's just a step to get there. So we're able to say that triangle APM is congruent to triangle BPM by side, angle, side, because it's this side, this angle, and this side. So that's SAS, because it's a sandwich. Sandwiches are sassy. I don't know why, but they just are. So now we can say that PM, because see how PM is right here at the end of the congruency statement, is congruent to, or PA, sorry, oof, I got distracted. PA, so this way, this part of the congruency statement, so PA is congruent to PB because corresponding parts of congruent triangles are congruent. Fantastic. All right, the converse of the perpendicular bisector theorem says the exact opposite. So before we were given that we have the perpendicular bisector, now we're proving that we have a perpendicular bisector. So this time we're just given that this and this are congruent. Or in other words, PA is now, we're given that PA is congruent to BB, and now we need to prove that that's a perpendicular bisector. In other words, that it's in the middle, and it's a perpendicular line with the other one. So, right here, are we given that we have a perpendicular bisector, or are we given that the QP is congruent to QR? I'm given the perpendicular bisector. You can tell because we have the right angle marked, and we have PS is congruent to SR. So we're given the theorem in this case. Okay, and we're going to find the length of QR. So first off, if that's the perpendicular bisector theorem says that PQ is congruent to QR. So now we can write that 3n minus 1 is going to be equal to 5n minus 7. So I'm just going to subtract 3n from both sides. And I get -1 equals 2n minus 7. I'm going to add 7 to both sides. I get 6 equals 2n. Divide both sides by 2. And I get n equals 3, which is fantastic, except that's not what I want. I want to know the length of QR. So I'm going to go to QR, and I'm going to replace n with 3. So this is going to be 5 times 3 minus 7, which is 15 minus 7, which is 8. So that length is 8. All right, I want you guys to try something similar. Here it asks you again, are you using the converse or are you using the theorem? What is the relationship between MB and JK? And you're going to find the length of JM. All right, once you do that, we will meet back here and we're going to prove that converse of the Pythagorean prove the converse of the perpendicular bisector. We're going to be using Pythagorean theorem.